So today we will go into a new chapters. We call it Introductions to Set. So what is a set? Okay. So a set is actually a collection of group of objects. So for examples, I give you a few fruits here: mango, durian, banana. So mango, durian, banana, we group it in the category of fruit. So we can say this is a set of the fruits. And then another examples here, we have like sunflower, orchid, tulip. So this is a set of flowers. So for example, you can also group other items like for example, okay, those who wear specs, okay, in a group. So we can say like Amy, Julian, okay, Jason, these three person wear specs, and then so we can say that is a set consists of those who wear specs. All right. So now in a set, okay, there's a few ways we can describe a set. Let's say you are given a set A like this: 1, 3, 5, 7, and 9. So we have three methods. The first method, we call it descriptions method. So in descriptions method, we will use words to describe. So how do we describe? So set A is a set of odd numbers. So odd numbers here you can see. So we use all the words to describe. So the second one, okay, we have here is listing. So we have our set A, okay, we put our alphabet A here, equals to, okay, we use this kind of bracket, okay, we have 1, 3, 5, 7, 9. And then the third method, we use set builder notations. So also we represent with A equals to open bracket. So X, okay, colon here, X is a set of odd number. All right. So let us try on some examples. So describe the following sets by using descriptions, listing, and set builder notations. We start with descriptions first. Okay. So this the first method, description. So how do we describe? Okay. So before that, okay, you must identify. Let the set. Let's say you want to identify this one as a set A or any other alphabet that you like. Okay, so let's say I let the set represented by A. Okay, so we will start with set A then. Okay, so descriptions. So how do we describe? So A is the set of letters in the word mathematics. All right. And then next we have listing. So listing, how do we list? So I would say listing is actually one of the easiest way. So A equals to, okay, we open out a bracket. So we have mathematics, right? So M, okay, and then we have A, we have T, H, I, C, S. We list all the alphabet. Okay, so some of you might ask me, okay, so now you look at here, your M repeated twice, right? So why it only appears once? So if let's say you have 2 alphabets or 3 alphabets, you only need to write once enough. Okay, same goes for your T. It only appears once in your listing. Okay, so next, if let's say we have set builder notations, how do we construct? So set builder notations. So A equals to X. We must start with X and then colon, okay? And then X is a letter in the word mathematics. And then we close out the bracket, okay? So that is how we describe our set. So we have 3 types: descriptions, listing, and set builder notations. So let us try another examples here. Let us try another examples. Okay, so even number which is less than 15. So first I need to identify what I want my set be. So let's say this one I put it as a set B. Yeah? So let the set be represented by B. Okay, so this will be your set B later on. Okay, so the descriptions okay, so descriptions always are very long lah with a sentence. So B is the set of even numbers which are less than 15. Okay, then if let's say listing, how? So listing B equals to 2, 4, 6, 8, 10, 12, and 14. All right. And our set builder notations. So for set builder notations, we have B equals to, open bracket, X to X, okay, is an even number, and X less than 15. All right. Okay. So, class, that is how we describe our set. So, if let's say you look at your set, class, if let's say you look at your set, okay, this one is set A. So, in set A, you consist of A, B, C, D. So, all this A, B, C, D is actually your, what we call, element. Okay, so like A is the element of set A, B is the element of set A, then we can put like this, A, element of set A. Okay, so this is the sign, okay, for elements. Okay, like a E, so B is an element for set A. So for this one, this part we write the set, this is elements. Okay, and then we have C, elements to set A, D, elements to set A also. All right, so let us try some exercise. So given that A equals to 23, 24, 25, and then B equals to number divisible by 3. Complete each of the following by using a symbol. Okay, this one is element, and this is not an element. So we look at the first one, 25. Okay, we look at the set A. So is 25 one of the element in set A? Yes, it is, right? So we put this sign here, and then we go to B. So B, okay, 23. This one B, set B. So number divisible by 3. So 23, can it divide by 3? Definitely no. So it's a no here. All right, we go to C. C, 15B. So is B divisible by 3? Yes, so 15 is an element in B. All right, so how about D? 11. Okay, so 11 for set A, so is 11 in the set A? No, so 11 is not an element in set A. Okay. So in a set, we will have numbers of elements in the set. Numbers of elements in the set. So given that R equals to vowels and S, okay, equals to factors of N. So now first list down the elements of the following set. Number 1 is your R, okay, and then number 2 is your S. Okay, we list down the R first. So R equals to the listing. We use listing method here. So vowels is A, E, I, O, U. Okay, then how about your S? So S, factors of S. Okay, so now this one, recap what we have in our factors. So 1 times 8, we get 8. So 2 times 4, we get 8 also. So we have 1, 2, 4, 8, right? So this is our factor. So we have all the listing already. So now, next we need to determine the numbers of elements in the set. So how do we determine the numbers of elements in the set? Actually very easy. So we just need to count how many you have in the set. So this one, 1, 2, 3, 4, 5. So the first one, okay, the number of elements in set R is 5. Okay, so we write N. Okay, N means number of elements. Okay, then we look at number 2. Okay, so S, number of elements in S. So we calculate, we count 1, 2, 3, 4. So we have 4 here. Okay, so in order to know how many of the numbers of elements, we just need to count how many elements inside that set. Then we'll know the numbers of elements. Okay. So up next, okay, we have empty set and null set. So empty set or null set, we have a symbol like this. Either you can represent using this symbol or this empty bracket. So what is empty set or null set? It's a set without any elements. So now, okay, meaning to say, you see in this bracket you have nothing, right? So a set without any elements. All right, we look at some examples here, then we'll give you a better idea. So given set P is a factor of 5 that can be divided by 2. Okay, so at least the elements of set P. So class, is there any 5 can be divided by 2? None, right? So P is actually an empty set. Okay, so you can use this symbol. Or if let's say you don't want, you can also write like this. So the choice is yours. Okay, like this. Up to you. So B, okay. So normally I myself, I would prefer this because later on I can calculate how many elements inside. Okay, so B, my N, P equals to 0. Okay, so now let us look at another examples here. Determine whether each of the following is an empty set. So A, hash equals to odd number, which is a multiple, okay, of let's say multiple of 4. Okay, so multiple of 4, odd number. Do you have any odd number which is a multiple of 4? Definitely no, right? So H equals to null set. Okay, so then we look at B, factor of add. So factor of add, we have, okay, so just now already got 1, 2, 4 add, right? So L equals to 1, 2, 4 add. So the numbers of elements here, we no need to write, but there is, right? So if let's say you want to count, there's 4 elements. So L is not an empty set. All right. So class, take note of here because this is also one of the common mistake of most of the students do here. So they will mostly mistaken this P equals to 0, same as this P equals to this. Okay, so this is wrong. Why? Because when we have P equals to 0 in the set here, this one actually you have 1 element already. Okay, so when we have ask you what is the elements numbers, is actually 1. Okay, it's not empty set. If let's say an empty set, it should be P equals to nothing in the bracket. Nothing in the bracket. Remember that? Okay. So next, okay, we have another thing here. We call it equal sets. So what is equal sets? So equal sets are 2 or more sets having the same elements. So what does it mean by same elements? We look at example 1. So examples 1 here, we have 5, 10, 15, 20 for set A. So set B, we have 15, 20, 5, and 10. Set C, we have 20, 5, 10, and 15. Okay, we can see, okay, 5, 5, 5. We have 3. 3 of the set, you have the same elements. So 10, 10, 10. Also repeating, 15, 15, 15, 20, 20, 20. So in these situations, we can say set A equals to set B. Set B equals to set C. We can also say set A equals to set B equals to set C. Or A equals to set A equals to set C. All right, so we look at example 2. Example 2 here, we have 5, 6, 7, 8, and 9. Okay, that one is the first set. Okay, so then we have our Q. Even numbers are less than 10. So let us list out the Q first. Even numbers are less than 10. Here we have 2, 4, 6, and 8. Okay, class, look at here. Okay, look at here. Do you have any the same? Okay, so we only have 6 and 8 is the same number, right? The rest is not the same. So we put this as P is not equals to Q. All right. So class, so today we will stop here. We will stop here. Okay. In our next part, we will go through the Venn diagram, universal set, complement set, and also the subset, and also some of the problems. All right, so class, stay safe and take care.